In example 7.10, we are given that the mean of the distribution is 2, standard deviation of the distribution is 0.5, and the sample size is 100. And we do not know what the distribution is. It didn't say it's a normal distribution or what kind of distribution. But when we look at the question statement, it says find the median, first quadrant and first quartile and third quartile for the sample mean. And because it asks for the sample mean, we immediately think about the central limit theorem. And it tells us the sample mean follow a normal distribution with mean the same as the original mean of the distribution, which is 2, and the standard deviation will be mu x bar. The standard deviation sigma of x bar will be the original standard deviation divided by square root of n. Now in this case, we have original standard deviation 0.5 and the sample size is 100. So square root of 100 is 10. 0.5 divided by 10 is 0.05. Or you can use a calculator to make sure you get the correct number. Because if this number is wrong, all your calculation will be wrong. So these are the information that we know from the central limit theorem, regardless of what the original distribution is. We project it to a normal distribution. So in that case, we can use our knowledge of the normal distribution. So normal distribution looks like this. And we know the mean of the normal distribution is exactly in the middle. That means 0.5, half of the data is on the left and half of the data is on the right, and they add up to 1. And what is the median? Median is the same as the mean. Median means half of the data will be less than that number and half of the data will be bigger than that number. So because it's a normal distribution, we immediately know the median, which is 2. Okay, so now we know the median equals to 2. How do we find the first quartile? So the first quartile is right here. And what does it mean? It means 25% of the data is less than the first quartile. 25%. Okay, so right here, 25% of the data is less than that number. And we convert that percentage back to an area. We get 0.25. Okay, so what is this number? And exactly what it's asking is, what is that x? Okay, what is that x? That will give us a z-score that corresponds to an area of 0.25. So you rewrite the question, right? First quartile is what x will give us a z-score that correspond to 25% of 0.2500. Okay, so now once we understand the question, we can answer the question. So the first quartile is what data value that will give us a z-score that corresponds to 0.2500. if you have a TI 83 or TI 84 calculator, it will be an easy answer. That x would just equals invert normal. So you invert the normal distribution and what are the information? The area, and you still need to understand the area is 0.2500, okay, just to be consistent with the number of digits and kind of like remind you, okay, that is an area. And the mean is 2. Now the standard deviation is given from the central limit theorem. Okay, we're working with this number. Okay, so it will be 0.05. So you enter in your calculator, you should get a number that's approximately 1.9, and you have to round it to 1 decimal more than what is given to us. If we look at what is given to us, we are given to 0.5 and 100. So we are given 1 decimal place. So we need to round to 2 decimal place. So 1.97 will be our answer for the first quartile. Now how do we find the how do we find the first quartile? Using the Z table, because not everyone have a TI 83, okay? And when you graduate from college and you want to sell your calculator, you won't have it anymore. But it's really easy to Google the Z table. So if you need to calculate a probability when you don't have a calculator, just Google a Z table and learn how to find that anything using the Z table. So in that case, we'll need to find the Z-score first, right? So first we need to find which Z-score on the normal distribution, standard normal distribution that corresponds to 0.2500. So you look through the Z table, you realize, I don't see that number. But that's fine. You get the number that's closest to it, because there will be rounding error anyways. So you will see 0.25, a few 0.25, okay, and 0.24 something. You need to pick the one that's closest to 0.25, which is this one. So once you find that number, you look up and you look to the left. So what row is it correspond to? It corresponds to the row negative 0.6 and the column 0.07. Now, when we get the Z-score, we do not add those numbers, we combine. So we combine those two numbers to get negative 0.67 as our Z-score. Why do we need to find a Z-score? Well, we need to find X, we need to know Z. Why? Because of the formula that we have been working with the whole semester. Z equals X minus mu divided by sigma, right? And in this case, we're working with sigma of X bar and mu of X bar because we're talking about the sample mean. So now we plug in the number. Negative 0.67 is my Z-score. I don't know X, because if I know it, I don't need to solve for it. I know my mean is 2. Okay, you go back up to the problem and what is given to us. The standard deviation is 0.05. Now, how do I solve for X? We don't like to work with fraction. So we multiply both sides by 0.05 to get rid of fraction. And then we add 2 to both sides. then we will just have an x here. And you enter that expression into your calculator. You should get 1.9665. But again, we have to round 1 decimal more than what is given to us. So when we round it, it's still going to be 1.966, right? So it'll be 1.97. So that will still be our first quartile using the Z table. Okay, to find a third quartile, now this is tricky, okay? The textbook doesn't tell you, but we're smarter than that. We need to use, okay, so here, what is that x? And it's telling us, okay, 0.75. 75th percentile is the third quartile, right? Okay, so this is 75% of the data. 75% of the data is less than that value. In another word, 25% of the data is more than that value. Okay, so we cannot find x directly, but we understand the standard normal distribution. Okay, so the mean 0. We know negative 0.67 give us 0.25 on the left, roughly. So then, if we know the symmetry, we know that the normal distribution is symmetric, then we know this value here, 0.67, will correspond to an area of 0.25 over here. Okay? What it means is 0.27 or 0.75. 0.75 is over here because they have to add up to 1. So we don't need to look up. We already know the z-score, 0.67. But if you must look it up, and I can just tell you, the area closest to 0.75 is 0.7486, okay, because it's 0.014 away from 0.75. And it still corresponds to a row of 0.6 and a column of 0.07. And we combine the rows and columns to get our z-score. So in that case, our x, and I will give you the formula for x, so you don't always have to solve a algebraic equation to avoid mistake. So x equals mean plus the z-score times sigma. We don't need to get a minus z-score, okay? The reason is z-score sometimes is positive, sometimes negative. So in this case, we just plug it in. 2 plus 0.67 times 0.05. So you use that, you enter that number into your calculator. You should get 2.0335, so 2.03 is our third quartile. So that's how we solve a problem like this.